Hello, it's Conan Horrors here with another episode of, well, Planet Quest. We're not going to be landing any Kerbals on planets today. No, today it's all about the probes. And this mission is akin, well, since it's the first probe mission in Kerbal Space Program for this series, it's akin to the Sputnik, but it's more or less a communication satellite, and in fact that's what it's called, is the ComSat Mark I. Now, in real life, the first satellites that we sent, they used 8-track tapes to store their data. That's something that might be interesting to you. The very first Voyager, well, Voyager 1 and 2, they both are equipped with 8-track tapes, and that's how they store all their data. And oddly enough, they run on Fortran, which, those of you who may not know, that's a very, very old language. Anyway, I need to make sure that this is active and looking at mission control so that it can receive commands. Okay. Yes, there's no worse feeling than trying to launch a probe and it can't communicate with mission control. It is the worst. Anyway, ready to stage and keep going. Okay. Now this communication probe is destined for a geosynchronous orbit. A geosynchronous orbit is an orbit which is at just the right height that the orbital period is equal to 1 day. So that means that it doesn't move relative to the surface of the Earth. In Kerbal Space Program, that's around 2,800 kilometers. It's closer to like 2,863, I think, but we're just going to aim for 2,800 because this mission has one purpose and one purpose only, and that is to be a communication liaison for another probe that we're going to send to the moon in this very episode. So anyway, I'm going to speed up the rest of this launch, and I'll probably talk over that, but anyway, to the speed up. Okay, so something very exciting happened. It turns out that this probe got to the apoapsis right at the right time. It has a very clear connection with mission control, so I didn't even have to do any of those eccentric orbits to get this point. And this probe is going to perform the maneuver all by itself. It's using the flight computer on board to perform that maneuver, so I don't have to worry about a light speed delay or anything like that. So here it goes, performing the maneuver by itself. And let's just watch the orbit, make sure it comes together. And this is a really awesome, very easy mission, assuming I still have enough Delta V. Oh yeah, I've got plenty. In fact, I think I have enough Delta V as well to do a cleanup of this mission. I don't plan on this being up here in space forever. After landing a probe on the moon, this essentially becomes space junk, and I want to get rid of it. I might keep using it, maybe, but its usefulness will run out at that point. So, last thing to do is make sure that it is facing the correct direction. There we go. Got that done. So I want it to be facing in such a way that the photovoltaic panels will always be getting sunlight. Here we go. Come on. Right there. So it's facing toward the south, essentially. It's facing toward the bottom half of the solar system. That way, no matter how it turns or rotates or anything like that, on this axis, it will always have a photovoltaic panel pointing toward the sun and will thus always have power. Now, to save power, I can also deactivate this. There we go. That's just a little antenna that has a very, very short range, and it should have been deactivated a long time ago. but it's a very short range, just barely into space kind of range, and is omnidirectional, not like these, which only point in a certain direction. And this game cheats a little bit. They're not pointed toward Kerbin, but they're still connected. Whatever, Anyway, you'll notice that I have two of these antennas. One is to mission control, and the other one is going to be toward our probe, the moon probe. So it's time to construct the moon probe and launch it. I'll meet you there. Okay, the moon probe Mark 1 is ready to go. Or Moonsat, sorry. This is the Moonsat Mark 1, and it is destined to the moon. Now let's get the communications set up. So this target will be the ComSat, which is in orbit now, and activate that oh shoot, was it called antenna? Then I'm going to leave this on the launch pad and go over to the ComSat and set that ComSat to communicate with our Moonsat. Alright, switch to it, and here we are. That's mission control. This one will be for the Moonsat, and activate. And its electric discharge is at 0. Fantastic. It has enough power. It has enough photovoltaic panels. It is fine. Everything is going well. Let's go back and let's get this Moonsat into space. Alright, again, if this were the Voyager, I keep using that as my comparison. Why not? The Voyager is a very interesting ship that is, or satellite that is on everybody's consciousness. They know about it. Anyway, if this were the Voyager, and this is an early satellite for our program, right? So it's a fair enough analogy. Anyway, if this were the Voyager, then its transmission between itself and the satellite that is in orbit would be about 160. Yeah, 160 bits per second. The 20 was coming from a different figure, so 20,000 bits per second is a very slow dial-up connection. Tells you how fast we get data from space. Anyway, again, I'm going to speed up the ascent, and I'll meet you when we get this guy into orbit. Uh-oh. Whoa, Nelly. Calm down. Oh, shoot. Maybe it won't get into space. Oh, boy. Come on, come on, come on. There we go. Fantastic. It may not be the most aerodynamically stable vessel in the world, or satellite in the world, but it at least is going forward. Now, in real life, that would have been an absolute terminal disaster. It would have exploded in the atmosphere. But luckily, this is not real life. This is a simulation. Just a fun little simulation. Anyway, again, assuming nothing else goes wrong, I'll just speed up this ascent. Okay, we're nearing the apoapsis, and I think it's safe to deactivate this antenna. There we go. Now, the reason that I left the antenna on, even though I had a connection with a satellite in orbit during the ascent, is, just for communication speed. Because it was closer, well, I'll show you. So, instead of having this long communication array, or line, that bounces off and comes back, which takes time. It takes 0.019 seconds for a command to get through. I could just connect through and here, and it was basically 0. But it does take up a lot of energy, so I just turned it off. Well, I mean, not a lot, but enough that it makes a difference. So anyway, time to... Oh, wow, that is not good. Okay, time to circularize, and then find a good time to aim for the moon. This is always the most boring part of any mission, is the circularization of orbit, unless something is going catastrophically wrong, in which case it can easily become the most interesting part. So let's ditch all that. It's going to become space junk. It's going to be in orbit forever now, or at least until I do a cleanup mission. But I'm not planning any cleanup missions anytime soon. Anyway, another stage, get that engine prepped and ready to go. And let's see, where is the moon? Oh, it's all the way out here. It says target. And in fact, now is probably the best time to go for it, so I will. How fortuitous. Alright, let's go for the moon. I have plenty of Delta V, more than enough to get there. Which is not the way that NASA does things. In NASA, they always scrimp and save. Again, I carried up more fuel than I needed. And of course, I do that just in case things go wrong. With NASA, they get things so well done and correct, calculated out before the mission and everything else, that they don't have to worry about such things as carrying up extra fuel. In fact, carrying up extra fuel is a bad thing because of all the weight that it means you have to take up with you. And that means more fuel to get off the ground, etc., and it just becomes very costly. Alright, I'm getting a close encounter here, and that's our encounter. So I don't know if I'm going to have radio communication when I get up here to the moon. So I need to set up an orbit insertion maneuver now and communicate that to the satellite before it arrives. Now, I don't want to go that way. I want to go this way. That's better. Okay. Like that. That looks right. So that should be an orbit around the moon, but it's showing up as a Kerbal centric orbit. It's showing an escape there. I don't know why it would have an escape, and it's saying it'll escape all the way out here. I think it'll give us plenty of time to set up any other maneuvers that need to occur. Now, it's going to take up 163 meters per second of Delta V, which I do not have in this stage. And I cannot stage if I don't have radio communication, which means this also becomes wasted space debris. There we go, dump that. Activate this engine. Now, in this stage, I have 856 meters per second of Delta V, which is more than enough to cover the amount that I need. Now, the amount that I need has changed, has gone up, and the reason is because that staging actually boosted the speed ever so slightly. It all the way down here, any small perturbation will have a huge effect way up here. And the vice versa is not true. In fact, it's the antithesis. A small deviation up here, or a large deviation up here, just creates a small deviation down there. Anyway, I'm going to set up the computer so that I'm going to send the command to execute at a setup time. I'm so glad that it does that for me. Anyway, let's warp. Our maneuver node is accomplished, and now we can look toward getting into a lower orbit. We have communication right now. It's a 0.05 second delay. I think it'll be fine. I can do things. So I'm going to get rid of that command. Then hold location. It's going to have a little bit of perturbation because every command is coming in slowly. And Now decrease the orbit. What I want to do is get really close. I don't want to get too close because that means more blackout time. But I can get close enough that I can start looking at a deceleration. Now I want to wait for this satellite, the communication satellite, to get on the other side of Kerbin. So I want it to process out here. The moon will be moving as well, but not as quickly. So I'll just wait for that to get on the other side so that I have communication and it won't be interrupted like it is now. There we go. Fantastic. So I'm going to set up a node over here, and because that's where it's going to be in blackout because it'll be on the other side of the moon, and come down where we have communication, and I want to just barely skim the surface. That's to maximize the amount of delta V that I have due to the Oberth effect. Now the Oberth effect is a very interesting thing that is just mind-blowing, and I still don't fully understand why it works. But essentially what happens is when you're really close to a large body and you're firing either a prograde or retrograde in your orbit, it maximizes your delta V. And I don't know. I don't know how it works. I don't know why it works, but it probably has something to do with relativity. I don't fully understand it. Oh no. We are out of electric power. We are out of electric charge because, I think it's because the sun was behind Kerbin. Oh no. Alright, we're going to have to do a couple more orbits. Yeah, out of power. I know. Okay, there we go. Oh, that was annoying. Another thing that you have to worry about. So, delete that maneuver, add a new one. Move it. Come on. Come on. There we go. So add a maneuver. There we go. Bring down our periapsis on the light side of the moon. Process this a little bit, actually, so that we're facing the planet. Because having communication is going to be absolutely vital to a successful landing. Otherwise, we're going to have some serious problems where it crashes. Okay, that'll do it. We'll try this again, execute. And by then, I think this satellite is going to be about here. The moon will be about here. Oh man. Everything is dynamic. Okay. Everything is as we expect it to be. While it's working, here we go. It's going to aim toward the maneuver node. Then we'll warp some more again. And hopefully this landing will occur. Come on, I'm counting on you. And I don't know how long I've been recording. I don't know how long this episode is going to be. I might have to break it up. Anyway, okay, we are set. Warp. Here we go. Fire. We have half of our electric charge remaining. Oh boy. This is, dealing with satellites and communications and stuff is difficult. It makes you appreciate all the stuff that NASA is able to do, right? And the military and everything else, all these other organizations. In fact, India has been getting onto the scene. Well, they've been on the scene for quite a while, really, with launching their own satellites. Many people don't know about that. Many people don't know that India has a very good space program. Alright, what's the delta V requirements for killing our velocity and landing? It looks like it's going to be, oh man, 300, 400, 500, about 600 meters per second of delta V. And that's in our next stage. I think we're going to be fine with this. Okay, come on. Yeah, So what I'm going to do is face the node, but I'm not going to do anything with it yet. Just going to face the maneuver node, and I'm going to manually land this. I think I can do that. Just try to manually land. Here we go. Warp to the point. Oh boy, scary stuff. I've got one try at this, and then we'll have to try another launch, and I don't know what's happening with the ComSat and whether or not it's processing. I mean, I know that it's processing because it's not exactly at the correct altitude and everything else. Okay, time to do this. So yeah, it's not at the exact precise height. What are you doing? You're supposed to be facing that node. Oh boy, I don't want this pendulum effect. It is not a happy effect. Do you even have... Okay, you have communication. How long are we going to have communication for? Alright, looks like we're good. This is processing, I know. Okay, but it should be processing so slowly that I have enough time for this mission to be successful and then to deorbit the ComSat. Like I said, this is its only purpose, is to have this mission land on the moon and perform its science and send that science back to Kerbin. We are about to run out of fuel in this stage, and here we go. This one still going by hand with nearly, well, with more than 4% of a second of delay. Okay, don't want that anymore. I want it to face retrograde. Get rid of the maneuver node. It's just facing retrograde. It should be mostly falling at this point. Yes, our horizontal speed is only 14 meters per second. So we can kill that, I think. In fact, I'm going to set this in this manner. Okay. Oh boy. There we go. Now we can come back to a retrograde specific. And this is really the hard part, is the landing, making sure we get this right. Yeah, I want relative to surface, not relative to orbit. Oh, here we go. Relative to surface. Sometimes I feel like a right idiot, you know? Okay, well, we've got our suicide burn distance is at 1 kilometer, well, 1.5 kilometers, and a suicide burn is, just a very quick definition, I can't think and watch this number at the same time. There we go. A suicide burn is where you, well, it's this. You start burning it at just the right time that you land at the exact same time that you reach a speed of 0 meters per second. Now, this is not a perfect suicide burn. I'm making mistakes and adjustments, and I don't think that perfect suicide burns actually exist. I think they're a unicorn of the scientific community. Oh no! Oh, right, this is the moon. It doesn't have that much gravity. I forgot about that. Anyway, let's try to kill this velocity. I mean, friction is doing its thing right now, but try to kill this velocity as much as possible. And there we go. Fantastic. So let's take our scientific observations. It still has connection. Come on, observe. There we go. And log temperature. That should be in there. Okay. And then this is going to be our big money maker right here. Observe materials bay and another mystery goo. I took 2 for symmetry, so I didn't have to worry about mass offset. But uh-oh, it's falling. Okay, and then we're going to transmit all of this data. Yes, transmit data, transmit, and transmit. and that's going to kill my battery. Hopefully I can transmit all of it before I run out of juice. Good. Only took away half of my power. So we can now decommission this satellite. This satellite is done. So deactivate this instrument. I always forget what it's called. An antenna. Deactivate the antenna. And this satellite is officially decommissioned. There's no longer communication with it. Anyway, let's go back to the Space Center and see how much science we have. I'm going to decommission the ComSat that's in orbit off camera, or maybe I'll decide to leave it in space. I don't know. Anyway, we have 79 science from that mission. And what can I unlock? Absolutely nothing, because they all cost 90. But at least I got, a lot closer. So we're going to have to send another manned mission, I think. But this is exciting. Successfully landed a probe on the moon. Not many people can say that they did that. Anyway, this has been another episode of Planet Quest. This is Conan Horace saying, have fun.